I'm going to go over part 2 of solving exponential equations and inequalities. So we began this, so you already know the basics. Exponential functions have a variable as an exponent. We're working on solving them right now. So what that means is that we are trying to determine the value of the x, and the x is part of the exponent. So I am going to go on to a new page for space, and I'm going to pick up with example number 4. So for this example, so example number 4. Okay, let's say that we had 1/3 to the x equals 27, and then how about 4x minus 1? All right, I'm just making this up. So, all right. So the steps to solving. We want to look at these base numbers. We need to get these two numbers to be the same number. So what we need to do is, my suggestion was to always look at the larger one. So look at this and figure out how can we rewrite 27. So if you think about ways to rewrite 27, we really only have one way, and that is writing 27 as 3 to the 3rd power. So 27 is the same as 3 times 3 times 3. All right, so we started with the larger one. We figured out how we can rewrite that. Now we need to get this one to match. Well, this one is 1/3, but we don't want 1/3. We want this to be, we want this one to be a 3 also. So what we need to do is figure out what exponent is going to cause 3 to become 1/3. So if this was live and you were here right in front of me, I would put the pressure on you to come up with the answer for how we can get 3 to become 1/3. But since it's a video, I'm going to go ahead and tell you that we do that with a -1 as the exponent. So at this point, I'm going to pause for just a second and go over to the side. This is how I explain the exponents to Math 8, because this is a skill, this integer exponent. You learn that in Math 8. So if we had 3 to the 1st, that would equal 3. 3 squared would equal 9. 3 to the 3rd would be 27. 3 to the 4th would be 81, and so on. So what's happening is that every time our exponent gets larger, we are multiplying by 3. We multiply that by 3, our exponent gets larger. We multiply this 27 by 3, our exponent gets larger. So the reverse and opposite should happen, meaning that if we go down, if our exponent gets smaller, then we must be dividing by 3. So if we go down, our exponent gets smaller, so we divide by 3 to get 9. And then our exponent goes down, so we divide. 9 divided by 3 equals 3. Well, let's keep the pattern going. So if we go down again with this exponent, so if our exponent goes down 1, that means we need to divide by 3. Well, 3 divided by 3 would be 1. So this explains why anything to the 0 power is 1. But let's keep going. Let's go down again. Let's go down another exponent. So every time we go down with our exponent, we have to divide the previous answer by 3. Well, 1 divided by 3 would be 1/3. All right, well, let's try another one. Let's say we go down again. So down another exponent means we're going to divide by 3. 1/3 divided by 3 is going to give us 1/9. All right, let's just do one more. So let's go down another exponent. So our hold on a second. There we go. Now we went down an exponent. Every time we go down an exponent, we need to divide by 3. 1/9 divided by 3 would be 1/27. So what you hopefully notice, and maybe this triggers your memory, is that negative exponents are going to cause reciprocals. So anytime we have a negative exponent, we need to think of that as dividing by that number instead of multiplying by that number. All right, so that's going to bring us back over here to this question. So I need to remind you that you are not allowed to change this problem. The only thing that you can do is rewrite these numbers. So this is still 27 to the 4x minus 1, and this is still 1/3 to the x. The difference is that we've changed what they're wearing. They're dressed differently, if you want to be kind of goofy, but they're still the same value. So a lot of times students will say, oh, let's multiply this side by 3. Well, if you do that over here, you have to do that over here. That's changing the problem. We're not changing the problem. We're just rewriting the base number with something that's equal. So now, once we get to this step, to pick up what you already know, we don't need the base numbers anymore. So our equation ends up being negative x equals 12x minus 3. So to solve this, we can subtract 12x from both sides. So that'll give us negative 13x equals negative 3. And then to solve for x, we need to divide both sides by negative 13. So x equals 3/13. All right, so what's going to be happening on the problems now is that one of your problems, one of your bases could very well be a fraction. You can still rewrite it with exponent. So what I want to do now is to kind of make up a list with you, which is hard since this is a one-sided video here, but to come up with the different ways to get numbers that you might be seeing in the problems that we're doing. So we've already talked about 81. Another way that you can write 81 is 9 squared, but you can also write 81 as 3 to the 4th. Sorry, marker's dying here. So, thinking of that, if we had 1 over 81, we could write this as 9 to the negative 2nd, or 3 to the negative 4th. So again, the only thing that's different is the negative exponent causes a reciprocal, which gives us our fraction. All right, so I want you to think of ways to get 16. We have 2 ways to get 16. I want you to think of how you can get 64. There's actually 3 different ways to get 64. I'd like for you to think of how you can get 1 over 8. And we have 2 ways to get that. Let's have you figure out how you can write 1/3. And we got 1 way to do that. And for the last one, let's have you figure out, sorry, the shadow is really bad on here. Let's see if we can fix that. Let's have you figure out another way to write 1/4, and actually we have 2 ways to do that. So if you will, pause the video, and then when you're ready, I will repopulate the video with the proper answers. All right, so there you go. All right, one last example. I want to show you one other type of problem that you could have. I'm going to squeeze it in right over here just for space. So I don't need to go on to another sheet of paper. So I'm going to call this example 5 over here. But let's say we had 7 to the x plus 6 equals 55. All right, this one is a little different because the first thing that we need to do is isolate our term that has the exponent on it. So what that means is I need to get rid of this plus 6. So we can subtract 6 from both sides. That'll take care of that. So now we have 7 to the x equals 49. All right, so now I'm going to rewrite 49 as 7 squared. So now the equation is 7 to the x equals 7 squared. So again, all of this is fair stuff because I moved this to the other side. I rewrote that. I haven't changed anything. I haven't affected the value of the equation at all. So now we can cross off our base numbers and we can see that x equals 2. So this example is to show you that sometimes if your the term that is the base with the exponent, if it's not isolated, you'll need to move whatever it is out of the way before you can set up your equal bases. Okay, I think that takes care of it. Remember, rewatch the video if you need to.